Hey guys, in this video we're going to cover a two-sample paired t-test. And now in the last video we covered single-sample t-test where there's only one sample comparing to a single piece of data. Now we actually have two samples of data. So in this example I have the question, a sales manager of company X decides to try a new training program for sales representatives. Compare the average customer satisfaction score from each sales rep before and after the training program. Is there a statistically significant difference? And if so, did the program improve the quality of the sales rep or, had an adverse effect? And the important part of this question that you instinctively should know to go to a paired two-sample t-test is because it says before and after the training program. So how you should think about whether or not to use a paired or just a regular two-sample t-test is this. Say that these two data, right, 4.2 and 7.3, this has to be the same guy, the same thing. So if I'm measuring, in this case, the score of, person A, it's before something and after something, or the productivity of a factory, before the upgrade, after the upgrade. It's still the same factory. So that's a key thing to understand when choosing this particular test. So here you have the before data set, and then here you have the after data set. So we're going to go into data analysis, choose the paired two-sample for the means test, t-test, and select the data. I like to have labels, so I click labels, and I'm going to output the data nearby. Click OK. Make sure that you can see everything here. Okay, so as you can see, the output of the paired sample t-test is virtually the same as the other ones. So on top here you have more of a descriptive statistic. It tells you the mean, the variance, so on and so forth. And on the bottom here, it tells you what potentially could or could not be. So once again, how to interpret this part. You can see, first of all, you see that the t-stat is negative 4.5. And the absolute value of this number is greater than the one tail and greater than the two tail. So right away we know that there is a significant difference. And in this question, the hypothesis isn't to say that I think there is a great effect, positive or negative effect, before and after. Instead, we're just asking, is there a difference? So we're looking at the two-tail once again. So here, the t-stat is greater than the t-critical for the two-tail, and similarly, the p-value here, the probability that the test was actually a fluke and it doesn't really count, is much smaller here than 0.05. So you can go to the answer section, and you can see here, because the absolute value of the t-stat is greater than t-critical two-tail, because the probability of that the null hypothesis is true is smaller than alpha, therefore we can reject the null hypothesis. And the null hypothesis being that there is no statistical difference. And so yes, there is a statistical difference before and after on the test scores. And we can say, yes, the training program did in fact improve the quality of customer service. And how do we know that? We just look at the mean, right? In fact, the after mean is definitely higher. How much higher? Well, we don't really care about that. We do know that it is statistically significantly higher based on the t-test. So, depending on how much data you have, how big the numbers are, how small the numbers are, the mean can be very similar or very different, but still don't really have a statistically significant number. I mean, that's kind of relative. So, but because we know that it is statistically significantly different, we can then look at the mean and be like, oh, of course, after the test, the mean is higher. So obviously, there's a higher test score. Okay? Hopefully, I didn't confuse you on this video. I think I did okay. Next time, we're going to look at t-test two samples that are not paired. Okay, and we'll talk about the distinction of that. Okay, I'll see you next time.